A blank model horse is merely the starting point. Artists spend weeks applying microscopic layers of pigment to capture the richness of a living coat. These pieces are significant investments, often commanding thousands of dollars and hundreds of hours of labor for a single finished model. Yet some of these masterworks carry a hidden physical expiration date, developing jagged cracks or losing structural integrity years after they were finished. This failure typically stems from the word resin, a label used so broadly that it often hides the specific chemistry of the material underneath the paint. Understanding the specific type of resin used is the primary factor in determining whether an investment will remain stable or physically degrade over time. In manufacturing, resin describes a broad category of hardened plastics, not a single uniform compound. The first major category is UV-curable photopolymer resin, which has become the standard for modern desktop 3D printing. The second is two-part polyurethane thermoset resin, the material traditionally used for mold casting model horses for decades. While 3D printing allows for rapid, on-demand production of intricate shapes, traditional casting relies on a physical mold to produce a solid, uniform object. These materials cure through different scientific mechanisms, and those differences dictate the eventual lifespan of the finished horse. Most 3D printed models are produced using SLA, DLP, or MSLA technology, processes that use light to turn liquid into a solid. The raw material is a liquid monomer mixture combined with a photoinitiator. When UV light strikes, it triggers the molecules to link into a cross-linked solid. The printer repeats this layer by layer, stacking microscopic slices to resolve fine details. This polymer network is formed by free radicals in a process driven entirely by light exposure. Because the chemistry is light-driven, the bonds created between these thousands of layers are often inconsistent. This leads to a long post-curing phase, where the material continues to harden and shift slowly long after it has been removed from the printer. 3D printing provides immediate, high-resolution results, but speed comes at the cost of long-term molecular stability. The layer-by-layer construction method leaves microscopic seams throughout the entire interior of the horse. During the printing process, small amounts of raw, uncured liquid resin can become permanently trapped inside these microscopic gaps. As the model continues to post-cure over months, internal tension builds around these trapped liquid pockets. This persistent internal stress causes the photopolymer to become increasingly brittle. Eventually, the material can no longer hold the tension, resulting in jagged microcracks splitting through the smooth surface and the paint above it. The internal chemistry of a 3D printed model remains active, shifting and contracting long after printing ends. Traditional manufacturing uses a different path, mold casting with a two-part polyurethane thermoset resin. Unlike the single liquid used in 3D printing, casting involves mixing two reactive chemicals, polyol and isocyanate. Mixing these parts triggers a heat-generating chemical reaction that is independent of light exposure. This reaction forms long, dense urethane linkages that interweave throughout the material. These linkages create a highly cross-linked thermoset polymer backbone that is chemically stable once cured. Because the material cures as a single mass inside the mold, the finished horse is one solid, continuous object without internal layers. This continuous structure removes the risk of trapped liquids and internal seams causing 3D prints to fail. A properly cured polyurethane casting is physically tough and resistant to impact. Polyurethane retains a slight flexibility, allowing it to expand and contract with temperature changes without fracturing. This resistance to environmental stress ensures the model remains a stable base for the artist's work. While 3D prints can show signs of brittleness within months, polyurethane castings are known to remain structurally sound for decades. Traditional casting requires more labor and time than 3D printing, but the resulting models are built to remain stable for decades. When evaluating a model, the choice is between the immediate availability of 3D printing and the long-term security of traditional casting. 3D printing provides incredible detail and accessibility, but it relies on a layered structure that is inherently prone to brittleness. Traditional casting is a slower, more expensive process, but it produces a chemically stable, permanent asset. Both methods have their place in the hobby, but failing to verify which material you are buying can lead to the eventual loss of the model. 3D printed resin is an excellent choice for casual display models, where immediate detail and lower cost are the priorities. Casual buyers should handle these models with care and recognize that the material may change over the coming years. Cast polyurethane is the standard for high-end collectors and artists who require a stable foundation for their work. For heirloom pieces or expensive custom commissions, polyurethane thermoset is the only way to ensure the paint job is protected by a stable structure. Before purchasing, always ask the artist specifically if the piece was 3D printed or mold cast. Never accept resin as a complete answer. In the world of high-end model horses, the chemistry beneath the paint is what ultimately determines the life of the art.